We're going to do a quick reminder about the graph of the square root and the cube root parent functions, because we're going to be needing those today in order to do our other graphs. So first of all, we've got the square root parent function here, which is just f of x equals the square root of x. That one has kind of a starting point, if you will, at the origin, 0, 0, because if you put in 0 for x, you do get 0 for y. Then it's got a point at 1, 1, because the square root of 1 is 1. And then there's another point at 4, 2, because the square root of 4 is 2. And then there's another one that fits on this graph at 9, 3, because the square root of 9 is 3. Now this one has no points to the left of the y-axis, because the x values over there are negative, and a negative x value would mean that you're taking the square root of a negative number, which we know is an imaginary. There's no room for imaginary numbers on our Cartesian coordinate plane here. So I'm going to connect these. And then the pattern continues off toward positive infinity for our x values forever. So looking at the picture there and also thinking about what we discussed, the domain of this would be all the x values that are greater than or equal to 0. And then also looking at the picture and thinking about what we discussed there, the range would also have to be all the y values that are greater than or equal to 0. Because when you take the square root of a number, you're always going to get a non-negative answer. Our second one is a cube root parent function. So for the cube root parent function, again, it does have a point at 0, 0, but I wouldn't really consider that a starting point on this one. We'll come back to that in a minute. There's a point at 1, 1, because the square root of 1 is 1. The next nice point that fits on this graph would be at 8, 2, because the cube root of 8 is 2. Now, what makes cube root so much different is you can actually take the cube root of negative numbers. So that means there's a point at negative 1 on here, because the cube root of negative 1 is negative 1. And there's also a point at negative 8, negative 2, because the cube root of negative 8 is negative 2. So now that I've got a few points to work with, I can kind of see the shape here. And I'm going to try to get it drawn in here. It's a little bit difficult on the computer. I think I did all right. All right, so that's what that one looks like. It's got a little wiggle in the middle, and it does continue on forever toward both positive and negative infinity for our x's. So for this one, the domain, like we were just discussing, x can be anything from negative infinity to positive infinity. So that would be any real number. And this is the notation that we use for that. For the range, now I'm just looking at the graph, you might assume that it kind of levels off a little bit, but if you think about it, think about a very, very large number of x. Like if we continue going out this direction for x, and let's say we got to, well, let's just do 1,000. The cube root of 1,000 is 10. So once I got to 1,000, it would finally get up to 10, which is about right there. Now, 1,000 is way, way, way out there, of course. So it is climbing. It's just climbing kind of slowly. But since our x values can go out to positive infinity, that means the y values actually are going to climb to positive infinity also. Same on the left. They're going downward though, so they're heading toward negative infinity just very slowly. So the range on this one is also any real number. The next bit of our review here is for our transformations. Now we've been studying transformations all year long. We've looked at them with every single unit that we've studied so far. And so this is what they look like with the square root function. Again, this number that's in the front here is, the negative that's there, that would cause a vertical reflection or reflection over the x-axis. The a that's here is a vertical stretch factor. The h, the minus there, that's inside the radical. You'll notice on this function, and that causes a horizontal translation. And remember, those are kind of backwards from what you think they ought to be. So if it says minus, it actually goes to the right. And if it says plus, it goes to the left. And then finally, we have k on the end there. Notice that that k is being added outside of the radical. And that one is a vertical shift. So that would cause it to shift up or down k units. And the k's, the k's behave just like it appears. So if it says plus, it goes up. And if it says minus, it goes down. So now I want you to answer a couple of questions on the Google form.